Hello children, welcome back to my channel. The chapter is number systems for standard 9. This is part 3. So in part 2 we had discussed about the rational numbers, converting the non-terminating recurring decimals to fractions. Now here we will be discussing about the irrational numbers. So the irrational, we said rational numbers are numbers which are either terminating or non-terminating but recurring. But in irrational numbers, they are numbers which are non-terminating and non-repeating, repeating or non-recurring. So it is point, for example, 0 2 0 2 2, 0 0 2, 0 0 0 2 2. Those 0 and 2 are repeating, there is no proper order. So in the earlier for rational numbers, you would have noticed 0.33333 was getting repeated. So you were able to write 0.3 bar. So here you cannot write it like that. So the irrational numbers are numbers which are non-terminating and non-repeating. Similarly, you have all the roots, root 2, root 3, root 5. Root 4 is not an irrational number because root 4 is equal to 2. So root 2, root 3, root 5, root 6, etc. they are also irrational numbers. Then cube root of 2, fourth root of 9 and etc. Then another example is pi. Pi, we generally pi is a irrational number. The value of pi is this 3.1415926535 and it goes on, and there is no proper order. So it is non-terminating and non-recurring. So it is an irrational number, but we generally say pi equal to 22 by 7. 22 by 7 is a rational number. So 22 by 7 if you divide, you will get 3.142 and so on. So the first three, in the decimal part, the first two decimals 1 4 are similar to this. Hence, for calculation purpose, we take pi equal to 22 by 7. But actually pi is an irrational number, 22 by 7. Pi is irrational, but 22 by 7 is rational number. Now coming to third. This is a special type of irrational number. It is an irrational number which is of the form nth root of x, where x is a rational number. Examples: cube root of 4, cube root of 5, fifth root of 2, etc. Actually, you write 2, root 3. It is square root of 2, square root of 3, but since for 2 we generally don't write it, nothing is written, that means it is square root. Others we say cube root, fifth root, nth root and so on. Now the laws of surds, it's similar to the laws of exponents that you have done, and you know nth root of x can be written as nth root of x is actually x to the power of 1 by n. You can note down this also. Nth root of x is equal to x to the power of 1 by n. Now the laws, it is similar to the laws of exponents. Nth root of a into nth root of b. If the order, see n is called the order, if the orders are same, then you can multiply. And similarly, you can divide also, but that is not possible with addition and subtraction. So nth root of a plus or minus nth root of b, it will be as it is, you cannot add. So when you do the problems, you will understand all this, nothing to worry. So you can similar surds, root 2, 2 root 2, 9 root 2, where the orders are same, they are called similar surds. Now you can add, subtract, multiply or divide the similar surds. So see the example here, root 2 plus 2 root 2 plus 5 root 2. So the order is same, root 2, root 2, root 2. So you can add. So the coefficient of here root is 1. So 1, 1 plus 2 plus 5, 7 plus 1, 8, 8 root 2. Similarly, you can multiply root 2 into 2 root 2. So root 2 into root 2 will be 2. Because root 2 into root 2 you can write it as root 2 into 2. So it is root 4 equal to 2. And then 2 into 2, 4. Similarly, 2 root 2 minus 3 root 2, you can subtract minus root 2, and similarly you can divide 2. So similar surds are surds which are having the same order. Same order, sorry, it is not the same order. Same order also should be there, and the radicand, that is the inside part, also should be same. Then only you will be able to do these operations. Now dissimilar surds, the order is same but inside the radicand is different. Root 2, 3 root 3, 4 root 5, etc. So here also addition and subtraction is not possible, but you can multiply or divide the surds, but this order should be same. So root 2 into 2 root 3, root 2 and root 3 are not of this are dissimilar surds, but you can multiply. So 2 into root 6. Here cube root of 3 into cube root of 5. Here the order is same, but inside the radicand 3 and 5 are different. But you can multiply, see, because the order is same. So cube root of 3 into 5, so cube root of 15. So the orders are different, then you will not be able to multiply. So you don't have to worry, again as you do lot of problems, this concept will become clear. Now coming to the properties of irrational numbers. Now suppose A is an irrational number, then negative of that number is also irrational. So root 3 is irrational, minus root 3 is also irrational. The second one, rational plus and irrational is always irrational. Addition, subtraction, multiplication, division, everything, if you do with a rational and an irrational, it is always irrational only. So 2 plus root 3, 2 is a rational number, root 3 is irrational number. So 2 plus root 3 is always irrational. Same 2 into root 3, so it is 2 root 3 is again irrational number, and 2 divided by root 3, that is also an irrational number. Now if you add, subtract, divide or multiply a rational number with a rational number, you will get it can be either a rational number or an irrational number. So the examples will 2 plus root 3, now this is an irrational number. 2 minus root 3 is again an irrational number. 2 plus root 3 is rational plus irrational. 2 is an rational number, root 3 is an irrational number. Rational, this is rational plus irrational is always an irrational number. So irrational plus irrational. Now 2 plus root 3 plus 2 minus root 3. Now if you add it, root 3 and minus root 3 will get cancelled. So 2 plus 2, 4. It is a rational number. 2 plus root 3 plus 4 plus root 3. Another example. So 2 plus 4 is 6. Root 3 plus root 3 is 2 root 3. Similar surds you can add. So it is 2 root 3. So 6 plus 2 root 3, rational plus an irrational is always a rational. The same way you can prove for subtraction also. So try to understand this. In your exam they will ask you to give examples. So you may use these examples. Coming to the case of multiplication, 2 root 3 into 4 root 3. You can multiply 2 into 4, 8. Root 3 into root 3 will become 3. So it is 24, it is rational number. 2 root 3 into 3 root 2. Now the order is same because root 3, square root of 3, square root of 2. So square root, square means order. Order is 2. So you can multiply. So root 3 into root 2 will be root 6. And 2 into 3, 6. So 6 root 6 is always irrational. So when you multiply two irrationals, it can be you will either get a rational or an irrational. The same case with division also. So when you do more problems, you will understand this. So I'll see you again in my next video with problems related to this. So till then, try to understand this concept. So when you do the next part, it will become much easier. So till then, bye and good luck for all of you. God bless you all.